Well, dear students, again I'm here to tell you about work done during adiabatic change by the ideal gas or on the ideal gas. So as we know, suppose that we have and moles of an ideal gas. If dV be the change in pressure, in volume of gas at pressure P. Actually, when volume changes, pressure also changes. So we have let it here dV small, so that pressure captive contact, as I have told you earlier also, and then work done. dW is equal to PdV. If volume of gas changes, if volume of gas changes from V1 to V2, then work done. W is equal to integration V1 to V2 dW, or it is equal to, or W is equal to integration V1 to V2 PdV. Now the change is adiabatic. So here Poisson's equation will be valid, and we know during adiabatic process P into V to the power gamma is equal to K constant, where P pressure will be volume, gamma Cp upon Cv, ratio of molar species of ideal gas Cp. Now from here P is equal to K V to the power gamma. My dear friend, I am reminding you that we can adjust P1 V1 to the power gamma equal to P2 V to the power gamma, so on, and the product remain constant. Putting this value here, hence W is equal to integration V1 to V2. Away. It is K upon V to the power gamma into dV. Or you can write it as V1 to V2 K common outside V to the power minus gamma dV. And here please learn x power n dx equal to x power n plus 1 upon n plus 1. This formula I have told you many times. Integration x to the power x raised to the power n dx is equal to x raised to the power n plus 1 upon n plus 1. So these are mathematical formula you will learn class 12, and if you are present, okay, you can learn all these things. But it is must to learn. Now how to integrate this? So this W will come out K V to the power minus gamma plus 1 upon minus gamma plus 1 and limit V1 to V2. Sorry, V2 to V1. Limit is this, or you can write it as W equal to K upon minus gamma plus 1 outside, and it is V2 to the power minus gamma plus 1 minus V1 to the power minus gamma plus 1. As you know, P1 V1 is equal to P2 V to the power gamma equal to K. So if I take this K inside, or you can write here minus minus gamma. It is not V, gamma minus 1. I write here first K V to the power minus gamma plus 1 or minus K V1 to the power minus gamma plus 1. Actually, K can be written as here P2 V to the power gamma or 1 upon, sorry, minus gamma plus 1. These three mistakes are committed by everyone, the expert as well as learner. So K, in place of K, you can write P2 V to the power gamma into V to the power minus gamma or V2 sorry, by x to the power minus 2 plus 1 means x to the power minus 2 into x to the power 1 minus P1 V1 to the power gamma V1 to the power minus gamma into V1. Just to make it simplify, this become 1. So we are left here only 1 upon minus gamma plus 1. It is P2 V2 minus P1 V1. Sorry. If I take minus 1 common here, the thing is very simple, but for learner it appears, oh, I am going to do something big. No, this is not so big. It is a simple problem, but we people are actually, if I take here, so I can write minus 1 upon plus 1 or P1 V1 minus P2 V2, or you can write W equal to 1 upon gamma minus 1. For every gas gamma more than 1, I have told you gamma Cp upon Cv. I told you gamma Cp upon Cv. Please remember it. Also equal to 1 plus 2 upon F. F the degree of freedom. You know, for monatomic gas degree of freedom 3, for diatomic 5, then for polyatomic 6 or 7. So it is this one and P1 V1 minus P2 V2. You also know that PV equal to RT. So we can write here K and as P1 क्या होगा भाई? P1 V1 equal to nRT1 and P2 V2 is equal to nRT2. R gas constant, but these only when pressure volume change, the temperature change, and hence this actually is one equation which generally used to calculate now, or at least nRT, nR outside gamma minus 1 into T1 minus T2. This is also expression for work done by an ideal gas during adiabatic process. You know, in adiabatic process, heat is neither given out nor in. So, internal certainly change and hence temperature will change. If T1 greater than T2, initial, so W positive, W greater than 0, and hence from first law internal energy will decrease. T2 decreases, but internal energy of ideal gas totally depend upon temperature. Internal energy of ideal gas is a function of temperature, and if T1 less than T2, so W negative less than 0, means work will be done by the gas. Temperature will be internal, then that work done will be on the cost of internal energy. I have explained all these things while explaining the application of first law of thermodynamics. So today I told you work done during adiabatic process as well as isothermal. In case of isothermal, I told you W equal to 2.306 to nRT or log V2 upon V1, yeah, and then also or W equal to 2.306 nR nRT log P1 अपॉन P2। तो इन सब बातों को याद रखते हुए चलना होगा। And I will be now explaining you some numerical here. I have seen in every exam, whether it is board exam or it is competitive exam, there is always question from this chapter. I will take the numerical in next video. You please like the video, share video. These are important and simple. थोड़ा सा brain, we have to little apply your brain, and I feel because we will get tired of learning unnecessarily. Why? But you have to learn throughout the life. Still, in this age, I always find something new again and again, every day. When we go at any other place other than this field, there are so many things which we find and which we have not seen or not learned. Please keep on learning. Yesterday I was in a function where I got very meritorious students, meritorious people, ladies especially. That was, the function was meant to give distinction to the empowered ladies. I met ladies there, one Director General of Income Tax, a lady was there, many were there. So they are hard, the theme of all was there, we have to work hard, sincerely, regularly, without any getting tired or hurt. We have to learn every day. Thank you.